let's compare these two volumes to their open forms and see what happens to the values located inside them. Looking first at the sphere. In this angle, the highlight would be located up here above the halfway mark of the sphere. Well, if we cut off the halfway mark and what we have left is the bottom half, then that highlight is gone. We wouldn't be able to see it down here in the lower half of the sphere because that's all we're seeing, you see, the lower half of this sphere in this little bowl. Well, what does that do for us when we open it up and it has an edge? We're able to see inside the bowl and look at the range of values that occurs when we open it up and see the inside. They're almost reversed from what they are on the outside. That is, if the light side is on the left of the open sphere, or the whole sphere, when we open it up, the light is on the right-hand side because the cup is actually holding the light in this form. And when it comes around, then the dark side is the inside of this sphere. We do have an edge here, something that we wouldn't have on the original sphere, and that's where we'd catch the lightest highlight on the side that's closest to the light. The back side actually presents more surface to the light than does the front of this sphere. So its entire value back here is lighter than the first big massive value we see down here in the lower half. That's what gives us the feeling of open space. So anytime you're painting or drawing a vessel that is open in this rounded spherical shape, remember that the back side is going to catch more light than is the lower half of the front side. Down here we're catching a little bit of light on the pedestal of this little bowl in the same position that the light would be if it were a whole sphere. We're able to see this, of course, because we have the cast shadow here on the little bowl. Moving down to the cylinder, before it was solid. We could tell because the light was on the side closest to the light source, and it got darker as it moved away from it. It's just the opposite when you have an open cylinder. The light is caught in this back edge just like it is in the spherical shape up here. So the values are reversed from an open cylinder than they are from a closed cylinder. The lightest light is away from the light edge. Now, unlike the sphere, the cylinder still presents its full surface to the light. So it catches all of the light that it would if it were a solid object. So we still see the trail of light that comes across the table and up the side. This value on the front of the cylinder and the value on the inside of the back of the cylinder are the same. That was not true for the sphere. The value on the back side of the sphere is lighter than that on the front side of the sphere. One thing that makes lights and darks more obvious, and I've deliberately left it unpainted to show you, is the cast shadow. The cast shadow is such an important part of the entire image that we often forget that it's a value that sets up the other values. It's an important negative shape. A positive shape is one that forms the object itself. A negative shape is one that forms an object by painting the surrounding area of a different value. Notice how this cylinder takes on much more strength and depth of feeling once we put the correct values in the surrounding area. A lot of times students will say to me, I can't get the highlight light enough. when in fact they're talking about not having the surrounding values in the correct relationship to the object. It's impossible sometimes to make an object look like it has a light because we have a limited range of values. So you have to control the negative spaces that surround the positive shapes of the objects we're trying to paint in order to make their values feel resonant and make us believe what we're seeing. This is a cone shape that I've deliberately left with no cast shadow to show you that sometimes an object will appear as if it's hanging in air if it doesn't have something to anchor it to the surface. So let's see what happens with this rather bland looking object once I put the light and the cast shadow on the surface. It's a case again of painting not what's on the object, but what's next to the object to make the object appear brighter or to have more contrast. Here comes our cast shadow. I think you can see from this example how the surrounding negative shapes are really important to describing any object that you want to paint. So don't forget the surroundings. They're as important as what you put on the object itself. Now let's talk a little bit about the cone. The cone is more similar actually to the sphere than it is to the cylinder, because this is a downward facing plane as opposed to the cylinder, which has a flat perpendicular plane to the light. So the value that we would put here for the lightest value on this little cup is going to be darker than the value we put back here, where the inside of the cup is facing the light at a more perpendicular angle. This value will be lighter than the value on the front of the cup. That's what gives us the separation between the front and the back and creates the three-dimensional look of the cup. As it rounds toward the light, we pick up the shadow area inside the cup that's not receiving any direct light. And this dark next to the light in the front is what gives us the circular feeling of the cup. And finally, we have our cubic rectangle. I've taken the lid off this little box, and this presents some really interesting value relationships in here. We still have our original relationship of the lightest corner being the one closest to the light, getting darker as it goes away. Our core shadow here on the shadow side of the box being darker next to the area where the light strikes it, getting lighter as it goes toward the back of the box due to reflected light. But now let's compare what happens with the inside of the box to the outside values. First of all, the light's being collected in this corner just like it's striking the outside here. This is the same plane. They're parallel. And the lightest area is going to be in this area. As it moves toward or away toward the back of the box or away from this light area, it gets slightly darker in value. But here's the interesting thing. This plane, the inside of the box, the value here is the same as it is on the outside of the box. But look at this cast shadow. This side is casting a shadow from the light, which is coming in at an angle like this, onto this back plane of the box, and this shadow is darker than any other value on the box. This is typical of cast shadows on objects where you can also see their shadow sides. simultaneously. The cast shadow on the object will always be darker than the shadow side of the object. And that's generally true for most any object that you'll observe.